everyone. In this video, I will show you how to find the moment of inertia of a T beam and program it in Excel. So you just have to change your dimensions and everything will update. So we have a T beam that is made of two rectangles. You have the pink rectangles that has a base B1 and 8 H1, and the blue rectangle that has a base B2 and 8 H2. So let's provide some information. Let's say B1 equal 10 millimeter, and the H is maybe 80 millimeter, and the shape to B2 is longer, like maybe 100 millimeters, and H is, let's say, the same as the other one, 10. Okay. Total there, we don't need any total. That does not make sense to have any total. It just makes sense for some other things. So we need to find the area. Let's get the area of the rectangle. It's the base time the 8. You program everything, okay? Nothing manually. Enter, and you can drag this formula. That will be enter this one. So the area of the pink rectangle is a little bit smaller than the other area. And we want to find the sum. So equal sum of this one, comma, this one. Why did I put it's a comma, and this one, enter. So now we have the area. We need to find the location of the centroid of each shape, because remember, we can do the theorem of parallel axes only from the centroid. So for the shape number one, the centroid is at h divided by 2. So it's h divided by 2. For the second one, do not autofill. For the second one, the y2 is there, but we need to have the same referential. So we need from the y equals 0. So that will be h1 plus alpha of h2. So it will be h1 plus h2 divided by 2. Enter. Here the sum does not have any interest. The area time y. Why do we need that? We need that because to find the centroid of the composite body, what we do is the sum of the centroid times the area of each element divided by the sum of the area, our average formula. So we will do A, the area, time the centroid. Enter. We don't need this one. Yes, we need the second one. I will drag them just to make sure I don't, make a mistake. And yes, we want the sum of those two. So equal sum of this one, comma this one, enter. And my y prime, or my y bar, it's usually y bar. It's easier to write y prime. Y bar equal the sum of the AY divided by the sum of the area. So it will be this one divided by this one. Enter. So 65, does that make sense? 65, that makes sense because H1 is 80. So 65 is somewhere, so this one is 40, somewhere there. It makes sense that our centroid is lower than the centroid of the pink rectangle because the blue rectangle is attracting that centroid. Should be very high. No, that should not be very high. So this answer makes sense. By the way, this is millimeter. Okay, if you want to write the unit. Distance. Now I need the distance between the y of each centroid of each element minus the y of the composite element. So that will be the y minus this one. Enter. And that will be this y minus this one. Do not drag your formula. If you drag your formula, you will have a value that is not correct. Make sure that you rewrite your information. Okay, E4 minus F6. Now the moment of inertia of each rectangle at their own centroids equal 1 divided by 12 time, 1 divided by 12 time their base time h cube. Why do I have a mistake? Oh, I have a multiplication there. Here we go. And you can just drag the first one. Okay. Let's remove a few decimals because it's a lot. Maybe one decimal. Okay. And now the final calculations will be your theorem of parallel axes. So I will add the moment of inertia about their own centroid plus the distance square and time the area of each element. And yes, we can drag this formula. And the total moment of inertia of this shape equal the sum of this one and this one. Instead of sum, you can write D3 or I3 plus I4. That doesn't matter. And the I, this is a millimeter fourth for the unit. So the moment of inertia of the T-beam here will be 1,335,000 millimeter fourth. It's always a very large number. We like to write them. Let me, okay, I will just call that number and show you. You can use it as scientific. That will, that's usually what that look like more. We like to write them as scientific. So make that little program for you and keep it because you can reuse it, just like change base and age everywhere, and you will have your data right away if you didn't make any mistakes in all your formula. So I will not redo any T-beam calculation to find the moment of inertia in the video in the problems. I will refer to that video and that Excel program. Hope that makes sense. I wish you a good day or afternoon or evening. Bye bye.